Hey guys, welcome back. What I wanted to do in this video is talk about 10 coding analysis questions. Now these type of questions are questions that come up on a lot of interviews, and they're definitely questions that you need to know. Now when it comes to coding analysis questions, the interviewer is basically trying to figure out how good you are at figuring out the solution to problems in code without the use of an IDE. Now, I know you've used a lot of IDEs out there, such as Eclipse, IntelliJ, or any other types of IDEs, but the IDEs, they can be used as a crutch sometimes. So, for example, if you were in Eclipse and you were to write some improper code, you're going to realize that there's an automatic compiler that checks to see if this code has been written properly. And if it's not, you have the ability to go back in, make a change to that code to ensure that you have code that can compile. Another thing is that when you're working with these coding analysis questions um, in an IDE, you can run the application and you know what the output is immediately. So basically, you can write code and then you can simply press the run button and then the application will run. But when it comes to these coding analysis questions, you have to know what the output of the code would be without the use of an IDE. And that's pretty much it. So this video is basically going to be used to test your coding analysis skills. Now, first thing I want you to do is grab a piece of paper and a pencil. Another thing, you can also use the comments section, but we're going to be using this paper and pencil for you to actually write down your answers to the problem, pretty much. Another thing is that I want you to pause the video after each question. So basically the way this video is going to work is that I'm going to first ask you a question, and then from there you're going to pause the video, look at the question or the piece of code, figure out the answer to this piece of code that I'm going to give you based on the question that I'm going to ask. And then after that, I want you to play the video once again, and then I'm going to walk you through the solution to that particular question. And that's pretty much it. So, without any further ado, let's begin. All right, so let's start off with question number 1. What will happen when you compile and run the following code? As you can see here, we have a piece of code here. Just go through the code, write your answer down. So go ahead right now and pause the video. Okay, now that you've written down your answer, let's walk through this code together. So as you can see, the first thing that we have are two variables. We have an integer variable, and we also have ourselves a Boolean variable. This integer variable, which is called output, is set equal to 10. And then we have a Boolean value, which is B1, is set equal to false. So after that, we have a conditional statement, this if condition here. And this conditional statement consists of two parts. This part, B1 equals true, as well as this part here. All right, so the first thing that we need to do is to determine the first half of this conditional statement. So we have if B1 equals true. B1, which we initially set here, is equal to false. So false equals true, which is not correct, is going to result in false. So for this part of the conditional, we're going to have false, and we're going to have to evaluate this now. So output plus equals 10. Output is 10 plus equals 10. That's going to equal 20. And then we're going to have 20 equals 20, which is correct. And this portion of the conditional is going to result in true. So false and true ultimately results in false. So what's going to happen is that we're going to bypass this if conditional and make our way down here, and this is what will be printed out. As you can see here, the answer is not equal 10. Not equal, and then the output, which we know is 10, is going to be printed out. Now, another thing pertaining to question number 1 I wanted to talk about is this thing called a truth table. I'm not too sure if you guys know about what truth tables are, but they're basically tables that are used to calculate the result of two Boolean values, pretty much. So in this case, as you can see, with the B1 equals true and the output plus equals 10 equals 20, we had false and true. So if we look at the truth table here, false and true, we're going to get a false. And basically, we're just going to bypass this conditional and this will be printed out. All right, so let's go to question number 2. Coding analysis question 2. What will the code output? What I want you guys to do is to just look at this piece of code on the right hand side, pause the video right now, and write down the answer of what will be the output of the code. So go ahead and pause the video right now. Okay, now that you have your answer, let's walk through this code and see what we get. Okay, now when you first look at this code, you realize that we have 2 classes. We have a class called value and we have a class called app2. First of all, let's start off with this class called value. Now this class called value, we only have one attribute or property, and that's going to be this property I, which is equal to 15. So this basically means whenever you create an instance of value, and if you were to call this property that we have, the value of that property is going to be 15. Okay, so the next thing that we have is this class here, app2. Now, as you can see in app2, we have this main method, which is a method that's going to be executed when we run the application. So you've created a new instance of app2, creating a new object here, and then from here we just simply are calling the first method. So t.first is pretty much going to jump to this method. Okay, now the first thing that's happening in this method is that we have a value that is set equal to 5, an integer value set equal to 5. Now after that, we're creating a new instance of value. So before we even progress more, when we create a new instance of value, if we were to call v.I, this will be the value that we get, 15. But what we're doing is that we're calling v.I, but we're assigning this value a new integer here. So 25 will now be assigned to v.I. All right. Now, the next thing I want to talk about is this method second. Now, second is a method that's going to take in this object value, and is also going to take in a variable I, which is going to be 5. Now, before we progress any further, I want to talk a little bit about pass by reference and pass by value. And what we're using here in this particular scenario is pass by reference. So let's talk about the differences between pass by reference and pass by value. Now, pass by reference is when you pass an object reference as a parameter. Now, when you do this, changes to these variables in the function will affect the originals. So that basically means that if you have an object and you pass it into a parameter of a method, and in that method that object changes, then after you exit that method, that value will be retained. Whereas in pass by value, you're passing a copy of the variable as a parameter. And this is mostly associated with primitive data types. So this basically means that changes are made in the function to these variables but do not affect the original. So it's pretty much just you passing in a value to a function, and there can be a change within that function, but once that you exit that function, that value will not be changed. All right, so let's go back to the code. We're here at second v comma I, and what's happening is that when we pass in v to this method, v is going to be passed here, and then if we pass in I, we know I that's being passed in is going to be 5. So we have v here, and obviously we have this I, which was originally 5. This is now going to be set to 0, so I is now 0 inside of this method. And then we have v.I, which we are now setting to 20. Now you remember, v.I was set to 25. Now we're taking the V value of this object and now we're setting it to 20. Now, what we have after that is a new instance of value. So we have a new instance of value, and we know that if we were to call val.I, we would get 15. So what we're doing is we're taking the object of V that's passed in, and what's happening is that we're passing in V.value. Yeah, okay, so we're assigning this val equal to V. We're assigning val to V here that we have. So in this method, V will actually be 15 because we're assigning whatever is in this new instance of value here. And then when we go system.out.println, we're going to get v.I, which is going to result in 15, and then we're going to have I up here, which is going to result in 0. And then after we exit this method, we just simply want to print out system.out.println v.I, and this will ultimately be equal to 20. So our answer is 15, 0, and 20. Now, you may be asking yourself, how did we get this 20? So what's happening is that the value of I in that object was changed to 20 in the method second. And this change does reflect even outside the method seconds. So if this VI is changed within this method and we exit this method, this change right here will be reflected here in this system.out.println VI right here. And another thing is that when we assign val to V, it is only valid inside the method second. So whatever change happens to V, even though we're assigning it to 20 here, this is only going to be effective inside this second method. But as soon as it makes its way outside of this method, v.I will equal 20. And hopefully this makes sense to you guys. If you have any questions about this, please leave them in the comments below. I'll get to them as soon as possible. Okay, let's keep going. Coding analysis question 3. Which variables can be referenced properly at line 12? Okay, so what I want you guys to do is just look at this piece of code. You see line 12 right here, and just ask yourself which variables can be referenced properly at line 12. So go ahead and pause the video right now. All right, now that you've written down your answer, let's walk through this together. Okay, so as you can see, the first thing that we have is a class. It's called outer. We then have two variables, public int A, which is equal to 1, private int B, which is equal to 2, and then we also have this variable here, final int C. And if we go inside of this method function, we have int D equals 3, class enter, and then within this class, we pretty much just have ourselves a method called iMethod. So which variables can be referenced properly at line 12? Well, the first thing that you should know is this E. Since this method has a parameter, E is obviously going to be a variable that can be referenced inside of line 12. Now, these are two other variables that can also be referenced at line 12, public int A and private int B. These can both be referenced at line 12, as well as the parameter here, final int C. Now, the reason why those variables can be referenced is because of this. Inner class, if the inner class is not static, it can reference enclosed objects and all its variables. So we notice that this inner class is not static, as you can see here. So it can reference enclosed objects and all its variables. So the enclosed object and all its variables. So inside of this outer, we can reference public int a equals 1, private int b equals 2, as well as final int c. Now, the reason it can reference this final int c is simply because this c is final, okay? And if we look at this second bullet point, variables in the enclosed method are only accessible when they are marked as final. Variables inside of enclosed methods are only accessible when they are marked as final, okay? As you can see, int d is not marked as final, so it will not be able to be referenced here inside of this iMethod function. So the answer is A, B, C, and E. These are the variables that can be accessed properly at line 12. All right, let's keep going. Coding analysis question 4. What will happen when you run and compile the following code? So go ahead and pause the video right now. All right. Now that you're back, what we're going to be doing is walking through this code, and I'm going to be explaining it to you. So what we have here is a try-catch clause. As you can see, we have a try block, catch block, and then we have a system.out.println at the bottom here. So what will happen when you run and compile the following code? First of all, let's look inside the try block. We have an int x equals 0, and then we have int y equals 5 over x. Now, if you're in math, you obviously know what this y was going to happen here. If you were to write the fraction 5 over 0, that means 0 times what will give you 5? Nothing times 0 will give you 5. So you're going to end up with an arithmetic exception. All right, so this will not be evaluated. You will end up with that exception. Now, is there anything that you see here that will go wrong once you try to run this code? Well, one thing that is going to go wrong is that there's going to be a compilation error, okay? And the compilation error will happen here at this arithmetic exception AE. Now, the reason that will happen is because we have a catch clause here, which pretty much catches all exceptions. So if anything goes wrong here, it's going to be caught by this catch block here. And this arithmetic exception is going to produce a compilation error. And the reason why is because this exception will never be reached. But simply because this exception catches this exception. So there's literally no way that this code can be reached because this exception E is going to catch it before it even gets here. So a better way of writing this would be to actually catch this arithmetic exception first and then catch this exception. So there's your answer. All right, so let's keep this moving. Coding analysis question 5. What will be the result when you compile and run the following code? So I want you guys to go ahead and pause the video right now. Okay, now that you've written down your answer, let's look at the code. Let's figure out what the answer is going to be. So as you can see here, the first thing we want to look at is public class test. So we have a class here called test. We then have a method, public void method. Inside of this method, we have ourselves a loop for integer I equals 0, I is lesser than 3, I plus plus. So this basically means if we were to just run this portion of the code, we would get 0, 1, and 2. That would be printed out. But then we go right below this for loop and we see the system.out.println I. See anything that will go wrong here? Well, there's your answer. You're going to get yourself a compilation error. We're going to get ourselves a compilation error because this I is never declared. So when you're inside of this for loop, this system.out.println is not going to be referencing what's in here, because the only way that this I can be referenced is by the code that is placed inside of this loop. So we're going to get ourselves a compilation error down here. Now, if we were to have another variable up here called int I and set that equal to a specific value, then we wouldn't get a compilation error. And this question is pretty straightforward, not too difficult, but it's basically used to just test your coding analysis skills. All right. Coding analysis question 6. What will be printed when executing the following code? So go ahead, pause the video, and write your answer. Okay, now that you've written down your answer, let's see if you got it correct. All right, so the first thing that we need to do is look at the code. And another thing I wanted to know is that when you're in interviews and you get code like this, don't try to rush through the code. You know, there shouldn't be any pressure, you know, when it comes to trying to analyze the code and figure out the solution to it. We all know that there's a process that you have to go through in order to make sure that you get the correct answer. So if you ever get a question like this, don't stress over it. Just, you know, take some time, deep breaths, and go in and figure out, you know, what you need to do to solve this question. All right. So we want to go back to this code here. As you can see, we have class X. And inside class X, we're pretty much just creating a new instance of Y. And then inside the constructor, we're pretty much just going to be printing out system.out.print X, the value X. And then, as you can see, we have another class, class Y. And this class only has a constructor. So whenever a new instance of this class is created, we're going to be printing out system.out.print Y. We're going to be printing out Y here. And then the last class that we have is class Z. And as you can see, class Z extends X. X will be the parent, Z is going to be the child. And once this class is executed, I'm going to create a new instance of Y. And whenever a new instance of Z is created, this Z is going to be printed out. And then we have our main method, which is the most important method. This is going to tell us exactly what's going to be executed when we run the application. All right, so let's first start off with this main method. So this main method is creating a new instance of the Z class. So, but we also know that this Z extends X. All right, so if Z extends X, then what's going to happen is that a new instance of X is going to be created. All right, so since a new instance of X is going to be created, because whenever you create a new instance of Z, you're also creating a new instance of X. So this new instance of X is going to be created, which means that it's going to jump up here to this class X and then create a new instance of Y. Now, whenever you create a new instance of Y, the constructor is going to be called for Y. So the first value that's going to be printed out will be Y. Now we go back up to X and we look at the constructor for X, which is going to be executed right after this instance of Y. So we're going to get X printed out next. Now after that, we're going to be done with class X, and then we're going to make our way back to class Z. Class Z is then going to create a new instance of Y. Y's constructor is going to be called once again. Then we're going to get Y printed out. And then after that, since we create a new instance of Z, Z is going to also call its constructor here. So our answer is D, YX, YZ. Hopefully this makes sense to you guys. I tried to explain it in the best way possible. If you have any questions about this, don't forget, leave them in the comments below. Let's go to the next question. Coding analysis question number 7. Which of the following lines are suitable to start a thread? So go ahead and look at this code here. Look at some of your options over here. And go ahead and pause the video. All right, now that you have your solution, let's see what we're going to do. So basically, when you're looking at this code that we have here, let's just start off at the top. We have class X implements runnable, and then inside we have public static void main, and here is the missing code that we need. But we want the code that is going to actually call this run method. Even though nothing's in here, we just want the code that is going to call that run method. And in order to answer a question like this, you have to know how to start a thread. So it's basically just something that you have to know. There's really, no logical breakdown of, how this works. You just have to know how to use threads, how to work with threads pretty much. And the answer you should have got was this. X run equals new X, then create a new instance of a thread, thread T equals new thread run, and then T dot start. So if you're trying to run a thread, the first thing you need to do is figure out which class either implements runnable or extends a thread class and create a new instance of it. So X run equals new X, and then after that, you want to create a new instance of thread. And within the constructor, you want to pass in the class that implements runnable. And then after that, you just would want to start that thread, because whenever you call t.start, that's automatically going to run this method, public void run. And that's basically how you start a thread. All right, next question. Coding analysis question number 8. What is the output of the following code? So here we have some code here. Go ahead and look through the code. Pause the video. Write down your answer. All right, now that you've written down your answer, let's see if you got this right. All right, so the answer that you should have got was this, 10,010. Now, let's figure out why you should have gotten that answer. So let's start off from the top. We have public class bool test. And then we have our main method, public static void main. And inside this main method, we first of all have this variable result, which is set equal to 0. And then we have 4 objects. So we're creating new instances of each one of these objects. Boolean 1, Boolean 2, Boolean 3, and Boolean 4. So as you can see here in the new Boolean for each one of these objects, we have different Boolean values. All caps true, lowercase true, camel case true, and then we have a false. So remember that whenever you're working with Booleans, this doesn't matter. No matter which way you type true, it's still going to set this value to true pretty much. So if you were to have camel case, B1 would be true. If you were to have regular case, B2 is going to be equal to true. Well, not regular case, but lowercase, B2 is going to equal true. If you have all caps, this will also be equal true. So just remember that. All right, so the first thing that we need to do is know about our equals. We have, as you can see, in these if conditionals, we have double equals, and we also have the equals method. So when you're working with double equals, you're comparing object references of the same type. So whenever you create 2 different objects, such as B1 and B2, the references are going to be different, because whenever you create an instance, they're referring to different locations in memory, pretty much. But if you're using this equals, that's actually comparing the content of 2 objects. All right, so if we start off with B1 equals B2, what's going to happen is that they don't reference the same location in memory. Okay, so we're not even, so it's going to actually bypass this conditional. It won't even go into this conditional. Now, if we do this, B1, if we go to this second if conditional, B1 dot equals B2, what's going to happen is that it's going to compare the content of B1 and B2. So we have B1 and B2. They're both going to be true, and we're going to get result plus 10. So currently result will be equal to 10. And if you go to B2 equals B4, these two do not reference the same location in memory because they're both two different objects. If we go down here, B2 dot equals B4, okay? So B2 dot equals B4, they don't have the same content. One is true, the other is false. So it's going to bypass this. And then finally, we have this if conditional down here, B2 dot equals B3. So B2 dot equals B3, they are both true. And what's going to happen is that the result that we already have, 10 plus 10,000, would equal 10,010, which is the answer that we have here. So hopefully you got that answer right. All right, let's keep going. Coding analysis question number 9. What is the output of the following code? So I want you guys to look at this piece of code, analyze it, write down your answer. So go ahead and pause the video now. All right, now that you're back, we're going to walk through this. So the first thing that we have here is a main method, public static void main. And inside we have a new object, which is set equal to new array list dot iterator. So if you've looked through this code, we're printing out so basically we're pretty much just printing out the Boolean evaluation of this. If I is instance of list, I is instance of iterator, and I is instance of list iterator. So this should be pretty simple. And the answer is this. We're going to get false, true, and false. Because I is going to be an object, and basically we're iterating through a list of elements within this array list. So it's going to create a new instance of iterator. So basically iterator only returns an iterator over the elements in the list. It won't be returning a list, you know, because that's pretty much, we're not even returning a new list itself. We're returning an iterator over this list that we have. So it won't return a list object or a list iterator object. So hopefully this makes sense to you guys. If you have any questions about this, leave them in the comments below. All right, finally, coding analysis question number 10. When will the float object be eligible for garbage collection? Not really sure if you guys know too much about garbage collection, but go ahead, pause the video now, take this question in, look at the code, and write down your answer. All right, now that you've written down your answer, let's go through the code. So as you can see here, we have a method that is called M. It's going to be returning an object. Now the question was, when will the float object be eligible for garbage collection? Now, don't know if you guys know about garbage collection, but garbage collection is an automatic form of memory management and is used to reclaim garbage. And garbage is memory occupied by objects that are no longer in use. So basically what that means is that if an object is no longer in use, it has the ability to be garbage collected. Okay, so let's look at each line of this code now. We have an object O equals new float, which is going to be 3.14f. And then we have the line right after that, object array OA equals new object. So basically what's happening here is that we're first creating an object, a float, and then we're creating a new array list, which has basically has one, it basically has space in there for one variable, pretty much, or one object. And then we're going OA at position 0 will equal O. So that means in this OA array, we're passing in this float value here, 3.14F. So that's being passed in here. And then what we're doing is we're assigning null. No, okay, I skipped the line. So what we're doing here is we're setting, yeah, okay, so I did this already. We're passing in, or we're assigning O to OA at position 0. And then what we're doing here is we're assigning null to O. Okay? So what we want to do is actually make sure that the object is no longer in use. All right? So this is the object that we don't want to be in use anymore. Because what we've done, we've placed this 3.14 into this array here. And this should make it a whole lot more clear. The answer is just after line 7. That's the answer, and I'm going to explain it right now. All right, so in line 6 that you see here, the reference of O is set to null, but OA at position 0 still maintains the reference to the float object pretty much. So as you can see here, we're taking the reference to the float object 3.14 and we're assigning it here. Okay, so it's assigned. So currently at this line, O is assigned to 3.14, but we're placing the value of that inside of this array right here. Okay. And as I said before, the reference to O is set to null, but OA at position 0 still maintains the reference of that float object. So as you can see in line 7, the thread of execution will no longer have access to the object, because we're now setting the value of this array list at position 0 to null. So that means that this object can now be garbage collected since it is no longer in use. So as I said before, when we work with the garbage collection, it's an automatic form of memory management and it's used to reclaim garbage. And garbage is memory occupied by objects that are no longer in use. So as you can see, when we set AO at position 0 to null, this will no longer be in use. So that's pretty much it. This OA at position 0, setting that to null, which pretty much means that this object won't be no longer in use. So that's pretty much it. If you guys have any questions about any one of the questions that I went through, 1 through 10, make sure that you leave them in the comments below. And hopefully you did good on this test. If you have any questions, leave them in the comments below. Don't forget to like the video if you've learned something from here. Also, don't forget to subscribe. And see you in the next one.